Okay, I actually just lost connection with my internet for a moment. So I've started to do this one already. It says, it gives you the volume, gives you the mass, and it tells you how to calculate density with mass divided by volume. So all you do, once again, is you do the mass divided by the volume, put it into the calculator, and there's your answer. Nice, easy, 2 marks. You don't need to know anything about mass, density, or volume. You don't even know what any of those words mean. You just need to know how to use these formulae. Okay. This question's a little bit tricky. Now I've worked out my density is 2.7 grams per centimeter cubed. I need to decide which one is that most similar to, because it's going to ask me what is the most likely type of rock the student had. Well, I calculated 2.7, so the answer is limestone. Now, what some of you might be thinking, let me just get the pen. What some of you might be thinking is, oh, if I don't know the answer to this one, if I can't work this one out, how can I get this one? There is such thing as error carried forward in exam. If your teacher marks it, they might write ECF. So if you realise in your exam that you need the answer to the previous question to answer this question, but you don't know how to calculate this one, you can write whatever you like here and just go, I don't know, it's equal to 5. And then you would go down here and say, well, the one that's most similar to 5 is, well, it's actually none of them. So let's say 3. Let's say you guessed it to be 3. And then the error carried forward would be basalt. So the correct mark using error carried forward would be basalt. So if you wrote that as your answer, then you'd get the right mark because you only get penalised once. I hope that makes sense. But anyway, error carried forward. So, okay, so for question 4.4, give one source of error that may have occurred when the student measured the volume of the rock. Okay, so you got to think this is methodology now. Like, this is you have to go back to that written question that you did and what could have gone wrong there. Well, if you're looking at, I've got my squash here actually to demonstrate. If I'm measuring the volume, how much water is inside how much liquid is inside this bottle, if I look at it at the wrong angle, I'm going to read it incorrectly. So that could be one way of doing it. There are a number of other things that I talked about to make sure that you do. So you could have also talked about the water sloshing about in the Eureka can or in the measuring cylinder. So when you're reading it, it's not settled. So that's not going to be clear. What else? Maybe the rock is not completely submerged in the water. So when you put you fill up the water, but you haven't put enough water in it originally. So when you put the rock in it, the water's not completely submerged. The water hasn't completely submerged the rock. So that would give you an inaccurate amount. Or you could talk, that is the volume. Okay, so you can't talk about the volume, the mass. So any of those things and many others that you could, and there might be some others you could think of. How would the error you described in, okay, so this, it depends on what you say, right? So it's quite tricky. So let's say you haven't put enough water. I'll go to this question, for that one. Let's take a snip of the video of the question. Okay. So, all right. So let's imagine the rock is not submerged. So we started to do this before. Let's say the tip of the rock is pointed, is above the water. So it looks a bit like this. I put some water in my Eureka can, or maybe my measuring cylinder. Then I put the rock in it, and the rock is not submerged. Now let's say the water's gone up by that amount. Okay, so it's gone up by that amount there, but it's not measuring all this rock above the water, because it's none of that has been none of that water rock above the water is displacing the water. So that's one way. Now, if you did that, what would the effect be? Well, the volume that you're going to read would be too low. Okay. What other kind of mistakes could you make, or could they have made? So another thing you could do is you got your Eureka can, and you've filled it up with water, or maybe you haven't filled it all the way up to the lip. You only filled it up to near the lip, like that. Okay. Oh. You filled it up to that, and then you put the rock in it. The new amount of liquid went above that point, and we had some water coming out. But the problem is, you're only going to get a little bit of the water, because it had to go up to the lip first, and then the excess after that poured out. So this would be, the volume would also be too low. Okay. So I could go in and give you lots of different examples here, but I mean, I'll just give you those two. You can probably come up with some other ones. Maybe you already had water inside the measuring cylinder for some reason. In that case, the volume would be too high. And yeah, it kind of depends, really. I could make this video. I could end up making the rest of the video just about this one question. Okay.